All right, let's go for it here. So P4, preparatory chapter number 4, deals with this whole concept of factoring. So we're going to run through factoring really quick. Factoring is probably the most important thing you can learn from Algebra 1. And if you got it then, you did good. If you didn't, then hopefully you got it in Algebra 2. As far as a process is concerned, I think factoring is the most critical process that you have. We do it in using calculus quite a bit, but we've come really to the end of factoring. There's a couple of tricks here and there with factoring, but for the most part, this is the way we think about it here. So we're going to run through just some practice problems here. I assume you guys know factoring. We're just going to jump through, see if we got it here. So first things first, practice problem number 1 is factoring by using the greatest common factor. And we're going to go from easiest to more difficult. And then we'll do a couple tricks along the way. So looking at this for factoring, letter A, what is the greatest common factor?
2x cubed.
Perfect, yep, 2x cubed. 2 is the biggest number that can go to 6 and 14. And for the exponents, all we do is we take the lowest exponent of the terms. Because we need a multiplier to get us to 5, we can have that. So always take the lowest exponent. All right, and then we always keep leftovers here. So leftovers, how about a 3x squared plus 7? We're good there. Can't give you the answer for the next one. All right, for B, all yours there. 7, I already gave you the answer. Okay, 7. Anything else? X squared, which is the lowest power on the x's of all the x's in all the terms. And leftovers would be x cubed plus 3x squared plus 5. Good there. All right, let's talk about this a little more here. We know this guy does not factor anymore for the purpose that it goes from x cubed down to x squared, and there should have been still an x in here somewhere, x to the 1 and then a 5, then possibly it could have still factored down some more. What we normally like to see, we like to see an x squared, then x to the 1, and then the constant term, right? 2, 1, 0. And then we know that still can possibly be factored. Okay, so really quick here. Factoring by taking out the greatest common factor. Jumping to the next slide. All yours, just for quickly practicing. These are the very easy ones. If you're bored out of your mind, you're doing good. All right, and I like to do the same way with the little X box like this. All right, there's something called also the rectangle method, and there's the area method. There's like 4 different ways to sort of think about. But this is probably the easiest way to do it. Take the top number here, take the middle number, because the way we get x squared we already know. So it's 2 numbers, multiply to 8, add to 6 at the same time. And 2 and 4 works just fine. If you wrote down 4 and 2, that's fine as well. So we know the only way you can get an x squared is if you have an x and x in front. So the x's are taken care of. It's really just the numbers in the back that we get these 2, and we're good to go. Got to be careful of the signs, of course. If you see minuses here, so also if you wrote the 4 first, the 2 afterwards, that's fine. This is also a totally correct answer, no problem there. Is that right? We can switch the factors around, and that's okay. All right, next one. 2 numbers, multiply to -10, add to -3. Cool. All right, I already got scared here for you guys here. Okay. X minus 5, and how about x plus 2? And then we have, and that's the basic factoring technique, right? There's more difficult ones here. Then we also have the special forms. So if you need to, you can write all these special forms down, or you can refer to, what do you guys say, which page in the text? I think it's on page 40. This is bottom of page 40. We got the difference of two squares. We got the perfect square with a positive middle term. We got a perfect square with a negative middle term. And then again, difference of cubes. Sum of two cubes. And notice the only thing that's missing here that you thought, no, that could have been here. There's no such thing as a sum of two squares. Doesn't make sense because the middles would have to cancel, right? Hopefully we covered that already here. So, just an example here. When is this? Let me actually do it this way here. Let me go to here. This one, I know it's a perfect square trinomial, but for this one, we really don't use a perfect square trinomial because it's easy enough, right? What we do here is we still do the old method here. We go like this. We say two numbers multiply to 4 and add to 4. 2 and 2. Easy enough. So then we have x plus 2, x plus 2. Or another way to write it, x plus 2 squared. Are we good there? Alright, and by the way, if you want to try the lecture notes already, you can actually just go all to the practice problems, is that right? If you read ahead, and of course the honesty question, raise your hand if you read P4, P5 prior to coming to class. Whew, alright, a whole 3 people. Alright. Okay, this is the one that we normally think about checking just to make sure maybe possibly it's a perfect square trinomial. Because we don't really like to factor a 9 in front if there's just a 1 in front. So the giveaway is the fact that at the ends you do have perfect squares. Is 9x squared a perfect square? Yeah, 3x. Is the 1 a perfect square? Yeah, 1's a perfect everything, right? 1's a perfect cube, perfect 4th power, 5th power. And so as I multiply these guys together, I get a 3x, and if I double it, do I get my middle term? Yeah, almost, right? Except it's a little negative in front right here. So we know that this, in its factored form, would be 3x, this sign coming down, and this term coming down here. If that does not give you that, then we have to do trial and error method of factoring. Okay, so there's that. Next on the slide here, difference of two squares. All yours for those. I think those are the easiest ones of factoring here, so I'll let you guys try them yourself. Alright, and I think you guys are done by now here. And this is real quick. Should be just x plus 4, x minus 4. Is that right? Difference of two perfect squares. 4x squared minus 25. 2x makes the 4x squared. The 5 makes the 25. So this just becomes 2x plus 5, 2x minus 5. And that is the factored form. Okay, and then the little tricky one of this part right here would be, how about if we go a little bit further, how about x to the 4th minus 81? And again, if you still need to refer to stuff, you can just open your book to page 40 to sort of have that out so you can see the different forms. For the exam, which is a week from today, you do have the privilege, I guess, yeah, of having a 3x5 card. Again, front and back, whatever formulas you need, whatever things that you're sort of missing, fill that one out prior to coming to class. Not like during class or right before the test. Okay, so this one, what happens here, this factors down to an x squared plus 9, x squared minus 9. And if you stop there, you got it wrong. As you look at it, you say to yourself, can I factor this down any more? Yeah, this one doesn't factor because it's a plus. You can't do that. But yeah, the second term, x squared minus 9, that's still a difference of 2 perfect squares. So then the first parenthesis stays the same, and the first factor stays as x squared plus 9, but the second factor does reduce down to a x plus 3x minus 3. Haha. Okay, raise your hands if I tricked you on that one. Tricked you. 2, 3, 4, 6, 7, 8, 9. Okay. Honesty. Thank you so much. 3 people that did not raise their hands. Not honesty. Not good. Okay. What ones don't reduce? Just to make sure that we understand, this guy does not reduce, right? There's no such thing as a factored form of x squared plus any number squared. And so as we've seen on the previous problem. Yeah.
Cubes do that.
Cubes, yes. Okay, so let's jump to the cubes. Let me jump to here. So can you, looking at page 40 if you need to, can you reduce x cubed minus 125? And then how about 27x cubed plus 8? Give you guys a whole 44 seconds. Alright, hopefully you guys did it already. If not, so the question is this a perfect cube of what? And that would just be an x. 125 is a perfect cube of? 5 is good. And you just need to follow the formula on page 140. If you have memorized it, that's great. But it'll be x plus 5. It's really, the first term is really the numbers, the terms themselves without being cubed. That's the way I remember it always. So it's just the singles, not the cubed here. In order to make x cubed, I need to have an x squared over here, right? That's the only way I can make a x cubed in front. In order for all the terms in the middle to cancel, notice we only have 2, we have to have an opposite sign here. That's the way I remember it. And then what goes in the middle is just a multiplication of the x and the 5. So 5x. And then, in order to get a 125 at the end, I have to multiply by a positive 25, right? Because negative 5 times a positive 25 gives you the negative 125. Once you see it that way, at least the formula makes sense. Like, oh yeah, okay, I gotta have it that way. Okay, and then the other issue is x squared plus 5x plus 25. Question comes up, Mr. H, does this reduce down some more? And x cubed, whatever's left over off x cubed, doesn't. Because the numbers won't work out, even though it's in factorable form. Okay, so 27x cubed plus 8. What is being cubed? To get a 27x cubed, 3x. What's being cubed to give you an 8? 2 is good. So because of the plus sign, the first term does have a plus sign, and it's just the terms themselves. So how about a 3x plus 2? Good there. In order to get a 27x cubed, the next term in the line should be 9x squared. It's the square of the 3x. Again, opposite sign of your first parenthesis, because you want to cancel everything in the middle. And then the multiplication of these two together here. So how about a 6x? And then in order to get an 8, I'd have to multiply by 4 to get there. Okay, so that is the sum and difference of cubes, and just flew through the special forms. So the other process that we have for factoring is something called factoring by grouping. Hopefully you guys remember that one. When do we use factoring by grouping? Usually it's used whenever you have 4 or more terms. And nothing gets to be factored out as a common factor. It's just stuck. So looking at this here, yep, there are 4 terms. And of course, like to see them in order. So degree 3, then degree 2, degree 1, and then the constant term. And again, go ahead of me if you know how to do it. Totally, this is just review. We won't get to any very awesome, cool stuff till chapter 3. So, how about the first two terms go inside the first parenthesis, the last two items go in the second parenthesis. And then what we do is we handle each of the parentheses individually. So what gets to be factored out of the first parenthesis? X squared is good. Leftovers? Awesome. And then now we're really trying to match these up together here. So if this was maybe like a 2x plus 6, we would take out a 3. But since there's nothing here to take out, we still want to be able to have a 1 in front, because we still want to have a little factor there. So leftovers would be x plus 3. And then this one's kind of fun. We look at these here as two different terms. We say what's common to this term and this term? X plus 3. So we take out a common factor, but it's called a binomial factor. We're taking out a binomial factor of the two terms. Leftovers would be x squared plus 1. And my question to you is, does that go down some more? Just kidding, it doesn't. Okay. Leading you on there. Okay, no, it doesn't come down because x squared plus 1 is against sum of two cubes, and that doesn't work. Okay, that was the easy one. I'll let you guys try the next one by yourself. Okay, maybe I should do the first step. We'll do the first step together here. So whenever you do factoring by grouping, you always want to have a plus sign in between your two parentheses. That's the only thing. So whenever you set this up, you have to have this little plus sign in between. So that minus 7x has to really turn into a negative 7x. So 28x cubed minus 20x squared. There's the first two terms coming down. This little minus goes with the 7, so I get a negative 7x plus 5. So the only little thing is always a plus sign in between the two parentheses. And I'll let you guys finish it off. 22 seconds. Let's go for it here. So the terms that be factored out of the first term would be a 4x squared. Leftovers would be a 7x minus 5. That's cool. And then if we look at the other parenthesis, hey, it's just exactly what I want. Well, no, it's the exact opposite of what I want. So in order to change the signs, let's factor out a negative 1. And now we have 7x minus 5, just like we want. And so taking out the negative. All right, taking out the binomial factor now. How about a 7x minus 5 on the outside, and we have 4x squared minus 1. And how many people stop there? Good, you got it wrong. Because now you have a difference of two squares. They should go down a little bit further. Didn't mean to embarrass. No, actually, I did mean to embarrass you. Roman, right?
How did you get that 7x minus 5?
Sure. Question is, how do I go from here to here, right?
Yeah.
Okay. So I look at this right here and this as two terms. And I say, what's common in both of these terms? And so just like a greatest common factor, what I do is I take out the greatest common factor. That was my greatest common factor. It goes on the outside. And then the leftovers are the 4x squared minus 1. Cool. All right, final answer. How about a 7x minus 5 and a 2x plus 1 and a 2x minus 1? Cool. How many got to that one? Did now. Okay, go. Okay, and then, of course, there's the tricky ones. Oh, and another little hint for lecture. If you want to go on to the next problem, right, you can always go on to, like, if you have your book open and you're on practice problem number 8, which is after example problem number 8. And if you say, Mr. H, I don't need your lecture, man, then on bottom of page 43, you can just write out letter C already, which is x squared minus y squared minus 2y minus 1. And you could already start doing that already, not having to wait. Semi-self-paced. in the classroom. How about that? All right, so factoring by grouping. Only little problem that sometimes they are the tricky ones. And on the tricky ones, I do have this mean laugh, like ha 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 ha. I got you. And then I'm so nice and caring that I'll tell you where the mistake is and stuff. Say again? Well, you have sarcasm on your shirt, so hey, come on. Let's go for it here. So, this is the way we set up factoring by grouping, is that right? You say, yes, Mr. H, it's all going to work out. I love this. I love math. And then you get to this step. And you say, Mr. H, I hate math. Because there's nothing we could do now, right? There's nothing that's common here, nothing that's common there. So every once in a while, factoring by grouping does not work. It's because there's hidden in here a perfect square trinomial. Doo-doo-doo. So as you look at the problem again, you notice, hey, look at that. I have an x squared over here, right? Then I have this little term. Look at that. Degree 2, right? Degree 1, and then your constant term. So I got 2, 1, 0. So let's see if we can work with this here. So factoring by grouping in the normal sense does not work. So how about this? How about we do this here? We take this x squared, because that's a perfect square, and the other ones don't even have x's in them. So how about if we put this together as its own perfect factor? The only thing this problem is this little minus in front. Because if you take out a minus 1, now this guy becomes a positive y squared, this becomes a positive 2y, and this becomes a positive 1. So, real quick here, can I turn this right here into its factored form? Something about a perfect square trinomial with a positive middle term. I think so. So minus sign comes down, and this, tell me if you guys agree here, this would be a y plus 1 squared, is that right? Alright, and again, I see the ghost faces at me here, like, Mr. H, what in the world did you just do? Okay, it's this guy here. Right, it's this right here, perfect square trinomial with a positive in the middle. And it turns into this right here. We did something like that in our notes, and let me jump back to it so you guys see it. It was practice problem number 3B. So it was maybe, no, actually 3A. It was this one right here, x squared plus x squared plus 4x plus 4. It was 3A. So this is 3A as a practice problem. You could also figure out like this, right? What two numbers multiply to 1 add to 2? It'd be 1 and 1. And because you got 1 and 1, you got the same factor. It'll be y plus 1 and another y plus 1. Okay, we're good there. Enough of explanation there. Still don't get it, please come talk to me here, because I don't like when you guys look at me like I'm from Mars. Okay, so now really we have a difference of 2 squares. Right? This is kind of like a squared minus b squared. So in that case, what we're going to do is we're going to write a squared minus b squared. So it's this form now right here. It's this guy, a squared minus b squared. Will be factored form would be a plus b, a minus b. Okay, we've got another little snag in the process. These guys are all just one single terms, right? This end one over here has 2 terms. It's a y plus 1. So to compensate, we need some extra parentheses in here. So this is the way I would write it. I would go x plus y plus 1. So there's my a plus b. Then I go with my a minus b, which is y plus 1. Okay, everybody good there? Extra parentheses in there, but just seeing where all the pieces are coming from. And yes, we do have to take out the extra parentheses. So in this case, the first term is going to be x plus y plus 1. Good there for this one. The second one's going to be x minus y minus 1. Perfect. Okay, because the negative distributes itself to the y and the 1. Okay, again, these are a little bit part of the tricky ones here. Boom. Okay, so we ran through the easy ones here. This is now the more challenging ones, and if you're still up and going and probably even ahead of me, that's even better. All right, the other thing that we do is we actually form perfect square trinomials. And so let's see how that's done here. Let's actually look at an example problem before we get to our practice problem here. Something looks like this. Let's say we go x to the 4th. So this is example problem number 9, I think. X to the 4th plus 3x squared plus 4. There's no way I can multiply two numbers to give you a 4, add them to give you a 3. Just can't happen. And so what we try to figure out how to do is we try to move things around so you still get a perfect square trinomial. So the question is, if I change this guy into a perfect square trinomial, it would have been just fine if this was a 4x squared, right? Because that would have been this term now. It would have been two numbers multiplied to 4, add to 4. Is that right? Yeah. So that means I need to get this guy to be a 4 instead of a 3. If I do that, I just can't add whatever I want to, right? So what I do is I add the 4x squared, but then what I do is I subtract off an extra x. So notice the combination of these two is still really a 3x squared. So then I move stuff around. So the 4 goes in front, this little x squared goes in the back, and now this guy is a perfect square trinomial, which becomes x squared plus 2. And so we have what we just did on the previous practice problem, right? It's really a difference of 2 squares again. And so that can still be factored down. So kind of fun little kind of thing there. Okay, let's try it, okay? I know these are more of the challenging ones here, so let's try this. X to the 4th plus 5x squared plus 9. All right, so I'm thinking to myself, you know, I see the x to the 4th, I see the 9 at the end, and that 5 is not happening here. So to form a perfect square trinomial, of course you guys in your head think this way, right? You think x squared plus 6x plus 9. That would be the perfect square trinomial, right? Because it would be whatever makes 9 would be 3 times 3. And if you double the 3 in the middle, it should give you that 6 that you want. So instead of a 5, I wish this was a 6. So let's do that. Let's go x squared plus, and I'm going to put in a, I don't know, over here. I don't know, what should we do there? So again, this right here, true. Tell me if you guys agree, is that the same thing as this right here? And so you almost have, for these problems, you sort of have to think ahead a little bit. You have to remind yourself of your perfect square trinomials. Okay, so I want the 6 in there. How do I get rid of the 5 and put in 6? I'd have to add 6x squared, subtract one of those x squareds to give me still remaining a 5. So if this right here were added together, I would still have a 5x squared. All right, let's move things around. Let's move this x squared out of the way. Let's bring the 9 in. So how about x to the 4th plus 6x squared plus 9? There's my perfect square trinomial. The x squared gets rejected to the back. And again, where's this used at? Sometimes in a few calculus problems here. So these are the tricky ones that you just like, oh, got it. Second semester calculus? Yes, definitely. And we actually start calling this something called U substitution, where we substitute certain things in here. All right, tell me if you guys agree. X squared plus 3 squared minus x squared. And with that, how about we change it up into a x squared plus 3? Now this time I actually don't need parentheses. I don't need a second set of parentheses because there's only one term in the back. We good? Not like on the previous practice problem because I was subtracting a whole term. And how about an x squared plus 3 minus x? And I'm good. Alright, the only thing is we really don't like to see it that way in its factored form. We like to see things in order, right? So like degree 2, then degree 1, and then your constant term. So each of these parentheses, how about let's put x squared first, then the x, then the 3. Second time, so the second parenthesis, how about x squared minus x plus 3. Alright, and these you probably may just want to check to see if they will reduce down some more. But I don't think so, right? Two numbers multiplied to 3 add to 1, that's not going to happen. And then two numbers multiplied to 3 add to a negative 1, that's definitely not going to happen. So then at that point you're done. Okay, and the only other form that's left for us to think about is this form here. Whenever you have a number that's not a 1 in front of x squared. If it was just x squared as your first term, those are the easy ones, right? Then you got this other number in here. It makes it all crazy. So the way the book shows how to do it is they say, you know what? There's a little trick to make it into 4 terms. So what we do is we split it off into 4 terms, and then we do it by factoring by grouping. So let's do that. Other math textbooks, they do something called the trial and error method. I think your algebra textbooks do that. Remember, so like putting in 2 values in the front, 2 values in the back, and sort of checking, does it make the middle? Like, yay, it did. If you remember that, that's good. If you don't, that's bad. But your book does a little bit different approach. So 5x squared plus 11x plus 2. You know, actually, let's do the book, the previous book way of doing it. Let me actually do this right here. I'll do it. If you guys remember from algebra, in algebra, what we did is we did this here. We figured out how many ways I can get a 5x squared. To get a 5x squared, you get a 5x times x, right? Boom, boom. And then you go back and you say, okay, how many ways can you get a 2? And this is nice because everything's positive. So you know it has to be a positive 2 and a positive 1, right? There's no other way around it. So then what we do is we plug it in. This is called the guessing part. We plug in the 2 and the 1. And what we do is we check just to see, maybe, possibly, I get the middle. So this is a 5x, and this is a 2x, and the question is, did I get the middle term of 11x? That means something went wrong. So then we do it again, and we just start switching things around. We usually like to keep the first 2 terms in the same spot. The last 2 terms are the ones we switch. So 1 goes here, and a 2 goes there. Now do we get the middle? Let's see, 5x times 2. 10x, 1 times x, x, and then we get 11x. And my trick teacher from high school, he said you always have to check the baby's head and baby with vampire teeth. Okay, that's the algebra method of doing it. We good? I just want to show it to you because sometimes that actually works a little faster. Works faster, especially if you have prime numbers, like in this case. Okay, let me show you what the book does. So we sort of have both of them in here. The book, what it does, it multiplies the 5 and the 2 together. And for the x box, it puts a 10 on top, 11 on the bottom. So can you tell me what 2 numbers multiply to 10 add to 11? 10 and 1, obviously, yeah. So what we do, we have just figured out a way to break up this 11x into a factorable form. And so guess this is a 5x squared. So 11x makes a 10x plus 1x. And you get the little 2 at the end. Hey, I've broken this up into 4 terms, is that right? Once I break things up into 4 terms, now I can do the grouping method. So this method really does involve a lot of guessing and checking. It's more of a straightforward method, probably just a little bit longer. We're good? So the first two terms go inside the first parenthesis. The last two terms go inside the second parenthesis. I probably would do this method if I had a whole bunch of different factors for the x squared and a whole bunch of different factors for the last term. Then like I'm going to do this method for this, so it'll be shorter. All right, how about a 5x goes out of the first parenthesis, leaving us x plus 2, and then we just leave a little placeholder of 1 out of the second parenthesis, and we have an x plus 2. And then we get ourselves x plus 2, 5x plus 1, and hey, did it match with our number over here?
Yeah.
I think it did, yep. Kind of reversed, but that's okay, doesn't matter. That's fine too. Sorry, waiting for a few people to finish writing it. Okay, so you guys get this method. It's before we start here, maybe I should show you real quick here. When would I use this sort of grouping method combined? Probably if I had something like this, x squared plus, let's see, x plus 8. So notice there's a whole bunch of different ways I get a 12x squared. 12x times x, right? Then how about a 6x times 2x? And then how about a 4x times 3x, right? There's 3 different possibilities for the first term. And then if I go back, I have 1 times 8 and 2 times 4. So 2, 3. I have 6 different possibilities here staring at me, right? I probably don't want to do guess and check right now. Maybe this process will probably be a little bit faster to do. We're good? If they're prime numbers, then it's a little easier. Okay, so all yours here. Try this yourself from beginning to end, just like we did on part A. All right, we good? Let's go for it here. So if you multiply the first two terms together, it gives negative 12 on top. You get a 1 on the bottom, so I need 2 numbers multiplied to negative 12, add to 1. 4 and negative 3 would work just fine. And it doesn't matter which way you go, negative 3 and 4 would work also. You're just going to get the factors a little flipped, but that's okay. So I write it as 4x squared plus 4x minus 3x minus 3. So notice that little middle term, if you combine these guys back together again, should just give you an x again. All right. First two terms inside the first parenthesis, last two terms inside the other. Careful with that little minus, right? That minus turns into a negative, so negative 3x minus 3. All right, what goes out of the first parenthesis? 4x is good by me. Yep, leftovers x plus 1. What goes out of the second parenthesis? Negative 3, awesome, x plus 1, and the grouping method works, awesome. Factoring out the x plus 1 leaves us with 4x minus 3. Okay, we good? Okay, let me show you one more method. Since you guys are sophisticated Math 15 students, and I only showed it to classes that I like. So, this I learned should tell you the background story just real quick here. So, went to college. A girl I really liked. So, I was supposed to go to pre-calculus class right away, right? Because I placed into pre-calc from high school. But then she was taking like Algebra 1, like Math 61. And so I convinced the dean, like, hey, you know, I'm really struggling with math skills. You know, the test, I just got lucky. The placement exam, I probably really need to go down to like Math 61. I seriously do. And so she signed off on it, saying, okay, yeah, you can. You know, I'm gonna fail. I'm gonna fail if I take Math 15. I'm scared. It was convincing. And so I went down to Math 61, and the Math 61 instructor was just brilliantly awesome. He had tricks galore, and he said he learned this from a Chinese student that he had a long time ago. So this is like top secret information, okay? We're good? All right. Oh, make a So I eventually married the gal. So yeah, see? There you go. So it was worth it, totally worth it. And I got this as a freebie along the side here, so share this with you guys. Okay, so instead of doing what we did on the last slide, which is this little guess and check method, right? And instead of doing this whole process of this guy, right? There's a little shorter way to do it. So here it is. I'm going to show it to you once. So you still multiply the 4 and the negative 3. You get yourself the negative 12. Just like the X box that we normally do, you get yourself a 1. And you ask yourself, okay, what two numbers multiply negative 12? I have to give 1, 4, and a negative 3. Okay. Notice what we've done is we've multiplied this top number by 4. We good? We've made it 4 times bigger. And so what we do is now we actually divide out the 4. So we do it like this. We go this and this. And we simplify it. One of them has to reduce, or both of them would reduce. So that 4 over 4 does reduce down to a 1. We good? So we go back over here, and I'm done. Because this number here, like we normally do, right? This would just be x plus 1, right? That 1 term coming down over here. We good? Now, if you have a denominator, this little denominator right here, any denominators are going to go in front of your variable. So this 4 is going to go in front of x, and the minus 3 is going to be your term at the end. We good? Technically, it actually works all the time, because if you go back over here, isn't 1 really the same thing as 1 over 1? So you have been doing it all along, just your denominator always went in front, your numerator always went in the back, but we just didn't see it until like, oh, that's right, that's exactly what happens all the time. Because your denominator is always 1 if this guy is 1. So it's just an extent. I call it Xbox 360, but you guys can call it whatever you want. Okay, good there. All right, one more section to do. We have an hour to do it in. So this now is going to be the rational functions here. So P5, rational functions, remember, are fractions. There's actually a slight distinction between fraction and rational function. And we get into it here. A fraction just means you have integers on top and bottom. So negative 4 over 7, that is considered a fraction because it just has integer values. By definition, if you have x over 3, now that's considered a rational expression. Rational expression means you can possibly have variables in it. Okay, good. Just another freebie. Okay, let's go for it. I assume you guys know this already. Let's look at just some examples here. Examples of rational functions. Again, by definition, a rational function is also a fraction. We're good? But a fraction is not a rational function. We're good? Because fractions can only have a 10 over 17. Rational functions or rational expressions could have 10 over 17, but also x plus 2 over 3. Good there? So rational functions are allowed to have also variables in them. Oh, that's funny. Never heard of that.
We have this like coffee and stuff, like your coffee getting like
Mhm.
all over your phones like that. So
That's funny. Okay, on with that. I might have to delete that from the video. Okay, let's go with practice problem number 1, and we're going to skip it because it does a whole humongous calculation on getting a false positive and stuff like that. That's not really what we want to do. We want to jump into just some practice problems here. So practice problem for this one is just reducing. And again, we're going to go into reducing, adding, actually multiplication, division, adding, subtracting. For these guys. Everything's sort of we did in algebra. Okay, so with this one here, remember whenever you simplify, you still want to factor. So we really are doing whatever we did in the last section. We'll be factoring this out. So greatest common factor of 2x cubed plus 8x squared. I can go with the 2x squared. Leftovers would be x plus 4. Factoring out the greatest common factor on the bottom. I guess a 3x would that do it? 3x. Leftovers x plus 4, and then all we do is we cancel off any terms that are exactly the same. So first of all, the x plus 4s are gone, but also the x squared and x. That reduces down. You have an extra x on top, and everything gets reduced down completely on the bottom. So how about at the end you get a 2x over 3. We good? And again, I'm going to just show you really just one of each type as we go through it here. Okay, part B does the same thing here. Let you guys a little bit of time here, finish off yourself. All yours. Cool, some of you guys are done already here. Just wait a little bit extra here. Probably the more difficult thing to do here is just factoring process. That's it. But if you got factoring good, we're good. So x squared minus 4 breaks down into x plus 2x minus 2. On the bottom, that is a perfect square trinomial. X plus 2x plus 2. In this case, I probably wouldn't write it as x plus 2 squared. I would write them individually. A lot easier just sort of cancel and kind of know what you're canceling. That's all. And one of the x plus 2's are gone. And because there's only a binomial left on top and another binomial, there's no multiplication. We really don't need parentheses anymore. So how about an x minus 2 on top, x plus 2 on the bottom? Which I didn't see anybody erasing anything, so I think everybody got that one correct. Good there. Then let's move on to multiplication and division. Let's see if there's any other little thing here. No. Okay, so let's jump to the slide here. No, you know what? I'm going to back up just a little bit here. Multiplication is pretty easy. Bless you. Don't need to write it down. Just kind of think with me here. If you have multiplication here, right, we simplify this as much as we can, right? Simplify this as much as we can. Simplify this, and then we just cancel anything top to bottom that are the same. So it looks like this: factored form, canceled form, and then finally the reduced form looks like this. And there's always a discussion among math people here. Would this technically be the simplest form, or would it actually be 2x plus 2 over x minus 1? Because there's still a operation of multiplication left in there. And so some math textbooks make you actually multiply in, and some math books make it into factored form and leave it in factored form because it's a lot easier to see. Your book keeps it in factored form, which is a lot easier to work with here. So, but division, you guys remember what we do with division? Something about we change it to multiplication, is that right? And we invert the denominator. Awesome. So all yours here. Go for it. Question kind of comes up on this problem here is what's up with the x can equal 0, x can equal -4, x, all this good stuff here. It's all the things that x cannot be. So if we look at just the numerator over here, we got ourselves a little problem, because if x is equal to 0, we would be dividing by 0 here in the top, right? That's our problem little there. Also, if x equals -4, if you factor this out, you find out if x equals -4, that's the same thing that happens. So it's trying to figure out any time that x, or you get a 0 in your denominator. That's our problem. For this one here, x equals -1 is a problem, because if this is a 0, no matter what, you're really dividing by 0 again. And then the issue here also is a -4, because if that happens, or a 0. So all the times that you would ever divide by 0, that's the problem. So that's why you have all these restrictions, we call them. Or we actually can call them domain restrictions. Anyways, hopefully you guys are done. I think you guys are done here. So the numerator is there. We're going to change this to multiplication, and we're going to invert our denominator on the bottom there. And then we're going to start factoring here. So on top, that factors into an x plus 1, x minus 3. On the bottom of first fraction, how about x plus 4 multiplying 7x squared? 2x cubed plus x, times x plus 4, and the bottom there. Good there? Check in your factoring. Again, factoring is the more difficult thing here. I think we can always cancel stuff easily enough. Bless you. Okay, and then canceling stuff. X plus 1 is gone. X plus 4 is gone. The only other thing is, how about the x squared and x cubed? So that goes away completely. We're left with an extra x on top. And the 2 and the 4 can still be reduced. So eventually x times x minus 3 on top. And a 14 on the bottom, is that right? Alright, how many got that one correct? Gave you enough time to do it. Okay. Awesome, that's good. Okay, so that is multiplication and division. What we want to get to is addition and subtraction. Those are the longer problems here. So let's jump to that. And I'll just let you guys go for it. This is the easy one because you have the same exact denominator. Again, it's practice. Alright, let me start it as well here, just so we're keep on going here. Only thing really to do here, because the denominators are exactly the same, we just have to multiply the 2 into here, so it just becomes a simplified fraction here, so everything else remains the same, except for that second fraction now becoming 2x plus 20. And then we keep the denominator exactly the same, so x squared minus 36 on the bottom, and then we're just adding the tops together like terms, gives you a 7x plus 42. And then the only question is, can it still be reduced? That's the question. Perfect, yep, 7 goes out in front, and the bottom is a x plus 6, x minus 6. On the top of 7, or greatest common factor of 7 gets out, and we got x plus 6 as well. Slow down just a little bit here, since I see people scribbling really, really quick. Alright, and x plus 6 are gone. Final answer 7 over x minus 6. That's our final answer. Okay, that's addition. I guess we should do one with subtraction real quickly here. It's all yours for subtraction. Still keeping up with us here. Hopefully you guys got it here. Same exact denominator. We're good. So we're going to just be subtracting the top. So 4x minus 3x is an x. 1 minus 4 is a minus 3. And then we also still have to check whether it could be factored and reduced. See some people nodding their heads. Yes, that is true. X plus 4, x minus 3. X minus 3 on top. And the only little thing here to get from is if the whole entire top cancels, you still have a little 1 on front, or 1 on top, because you have a unit fraction. So 1 over x plus 4. Okay, the difficulty comes in is when you don't have common denominators. That's not difficult. That's where the fun begins. So I'll let you guys try this one by yourself before. Alright, let's go for it here. So hopefully you guys got the common denominators here. So for the first fraction, x plus 2, x minus 5. Second fraction here, there's the common denominator. So you got a multiplier of x minus 5 to get your common denominator for the first fraction. So this is the new stuff. So that means that has to be multiplied on top as well. Remember, because whenever you multiply on the bottom, you multiply on top, technically what you want to do is be multiplying by 1. For the second fraction, x minus 5 is here, x plus 2 is your new multiplier, so 3x times the x plus 2. And of course you guys can probably go directly from here down to here, and that's okay. If you skip that little step here, that's fine. But you want to get to 2x squared minus 10x probably. And this one is a 3x squared plus 6x. Alright, got 4 erasers happening here, so I'll let you guys catch up in a bit here. Alright, still keeping that same denominator in factored form, and the top, 2x squared plus 3x squared makes 5x squared. How about a minus 4x as well?
So you want to leave like that, and pull the x out.
Good, good.
And do the x times.
So the question is, even if you factor, there's no common factor to cancel, and so now it doesn't matter which one you want to write, this one or this one. Either way is just fine. You probably should know that it's either way is fine. Interesting. When we're going to be graphing these later on, you want to see in factored form, because what you want to see is you want to see all the zeros. Then what you want to do is you want to put it into multiplied out form, because that actually shows you your something called your horizontal asymptotes. And so you sort of you needed to have both. Okay, B, all yours for another one, just for practicing. That was addition. Let's go on to subtraction. Alright, so let's go for it here. So common denominator should be x minus 4x plus 3. So your multiplier for your first fraction would be the x plus 3. Multiplier for the second fraction would be the x minus 4 as the now common factor. And then again, multiplying things out completely. Still keeping the denominators exactly the same, but on the first one we get a 5x squared plus 15x. Second one would be a 2x squared minus 8x. If you got to that step, I think you're doing real good. And keeping the denominator there, and we are subtracting now. So 5 minus 2 is a 3. 15 minus 8 is a 15 minus a negative 8, right? Is a 23x. Almost got me over here. Okay, so that's fine to keep it like that. If you wanted to check out the factored form, that's fine as well. So only the x gets to go out. Leftovers will be 3x plus 23, which does not reduce at all anyways. Okay, so we did multiplication, division, we did addition, subtraction. Now we move on to sort of a little bit of the more weirder ones, I guess we should say. So let's do that. There's just a few of them here. So first is this whole concept of the LCD, lowest common denominator. And part of the homework is you're just trying to figure out the lowest common denominator. So the denominators are going to get more complicated. That's kind of what we're doing. So for practice problem number 6, I got a whole bunch of weird stuff in our denominator. So there's one term here separated by a comma, and the other term is over here, and we've got to pick out the lowest common denominator out of all of this. So it's not just x plus 3 times x minus 4. All right, so how do we do this? We do it in sort of pieces, and this is probably the way I think about doing it. So first of all, everything has to be factored out because you can see each of the pieces. Second is I start off always with my coefficients. So no coefficient here. The coefficient of 3 here. So that means the 3 has to go out as my common factor here. We're good there? Then when I look at my variables of just x, my single term variable, I see an x squared over here, I see an x, and we're going to always take the highest power. Right, because we need those numbers to factor into our common denominator. Okay, and really when you take out the highest exponent at each of the factors, we do the same thing for everything else. So as we see x plus 2 over here, there's no x plus 2 over here, so the highest exponent would be x plus 2 to the second. Same factors here, x minus 2 over here, but this one is x minus 2 to the second power. So we're going to take out the highest exponent. So always take out, if you want to put a little asterisk next to it, just put highest exponent. So remember, factoring and common denominator, those are the two different processes, right? With factoring, you want to take out the lowest exponent. Whenever you're trying to figure out the common denominator, you want to take the highest exponent, because the terms that we started with have to multiply into that common denominator. Okay, so one for you guys to try, all yours. Of course, it's not in factored form. Alright, and this should be somewhat easy here. So the first fraction, we do have to put it into factored form, so x plus 5, x minus 5 there. The second fraction in factored form, notice I don't care about the numerator, that's what the denominator is, that's the issue here. So how about a x times x in front, and how about an x plus 5x minus 1 for the bottom? Alright, in this case, the common denominator would be, I need an x plus 5 to the 1 power. I need an x minus 5, then I also need an x minus 1 as my common denominator here. Okay, so let's go for it here. Let's jump to problems here. So it's really going to be adding, subtracting, except the denominator is going to be a lot more complicated. That's it. So let's work through these together, also because of time constraints here. If you can stay ahead of me, go for it. Give you guys a little bit of a head start, and then I'll just sort of start it as well. And then we'll also use the LCD to actually solve or simplify multiplication division problems as well. Alright, I'm going to start as well here, just real quick here. So on top, I have the 4, and factored form for this one should be x minus 2 squared, is that right? It's a perfect square trinomial with a negative middle term. On the other side, x squared minus 4 breaks down into x plus 2x minus 2. Alright, so the common denominator that I'm looking for would be, I need an x minus 2 to the second from here. This one has x minus 2 to the 1, but the highest power would be x2. And then I need x plus 2. So there's my common denominator for the first fraction. So looking from here to here, I need a factor of x plus 2 to multiply the top. Second fraction, x minus 2 squared, x plus 2. And what factor do I need? Oh yeah, I need an x minus 2 here, so x times x minus 2. Okay, everybody good there? Some of you guys already finished, that's a good thing. And let me just kind of finish it up as well here. So common denominator still stays. On top, multiplying it out, 4x plus 8. And the other fraction would be nx squared minus 2x. Adding everything up together. On top would then, in order, how about an x squared plus 2x plus 8. And the question is, does x squared plus 2x plus 8 factor? Almost like, seems like it should, right? Because of the 2 and the 8, they're both even numbers. Looks nice, but there's no way you can get two numbers that multiply to 8, add to 2. So we are done with that one. The next one has a little trick to it, so let's try this together. Let's see, the first fraction is already in factored form. Second fraction is not. So let's try it, and the little trick is you can simplify before you start putting it together. So I'm going to kind of go slowly so you guys can catch up with the writing here. So 2x on top. This guy's already in factored form, so nothing to do here. On the bottom it's 3 times x minus 5 squared. Alright, minus on the other one, 6x on top. In factored form, I guess the only thing we can factor out is the x, right? There's a common form of x. Leftovers as x minus 5. Okay, so before we start putting together common denominators, it is helpful many times to see if you can just simplify anything top to bottom of each fraction. So this one, I don't think so, right? 2 and 3 not going to happen. But this one, yes. 6 and 2 will go away. In fact, the x's go away right away, right? And then the 6 and 2 reduce down to a 3 and a 1. So why make it more complicated if you need to? Yes, reduce down a fraction beforehand, especially since you have it in factored form. So now in factored form, first fraction remained the same, but the second fraction now is just 3 on top, x minus 5 on the bottom. Really don't even need these parentheses here, but your job to finish it off. All right, let me rewrite the problem here on the next slide because I ran out of space. And then from here on out, let's see, the common denominator should be a 3x minus 5 squared. So the first fraction does not change at all. On the second fraction, I do have a multiplier of 3 to give us a 9. And then I also need another x minus 5. So simplifying the numerator of our second fraction before we start subtracting gives us a 9x minus 45. All right, and final answer, putting it all together here. You can write it as negative 7x plus 45, because technically you're subtracting a negative. And again, just want to show you this here. Sometimes whenever the coefficient of x is negative, sometimes, what the book does, it writes the positive number first, and then the negative coefficient of x. So this one or this one, these guys are exactly the same thing. No changes here whatsoever. So you can write both ways. Do want to mention also, if you have a negative here, it does change. If you want to switch things around, it changes into a subtraction symbol on the back end. Cool. Again, something from algebra. Okay, got 2 more problems and 10 minutes to go here, so let's go for it.
We can reduce that one down.
See again. Cool. Okay. All right, and then something called complex fractions. I think you've seen it before. Complex fractions are fractions that have fractions inside them. We've already seen it before when we did the division. Remember how we changed division into multiplication of the 2 fractions that we did it? But there are 2 different other ways to do it. You could do it that way. But method 1 is talking about simplifying the top, simplifying the bottom, and then doing what we did before. Method 2 is this whole concept of multiplying by this little LCD that we just learned. So let me show you let me go 2 different methods. I'll show you when you want to use which one, because there's a little bit of a discretion you need to have here. So let's go with let's go with it here. Yeah, let's do it that way. Let's jump to this one here. I should say it this way here. If for method 1, if you're going to use method 1 in that place, you can always use method 2. No, set it backwards here. If you can use method 2, you can always use method 1. But sometimes you want to use method 1 because it's really complicated. Good. At that point, then you want to separate them out into different pieces and start putting them together. So let's do method 2 for this one. Method 2 is to multiply through by the common denominator that you see everywhere. So in this case, the common denominator is the, well, where we get common denominator is the 3x over here, the 3 and the 3x here. So common denominator would be 3x, we good? So we're going to multiply this whole top by 3x and the whole entire bottom by 3x. So 5 over 3x plus 1/3. On the bottom, x squared minus 25 over 3x. So multiplying the top, multiplying the bottom, both by 3x. So this is method number 2. This is probably the easiest if you have almost like a simple expression here and a simple expression here. You can multiply by LCD. All right, you can just multiply into here like this. I like to show it as every single part. So I'm going to distribute the 3x to each of those pieces just so you guys can see it a little easier. You don't really need to do it. If you can get to the next step without having to write this intermediate step, that's fine too. But as 3x multiplies into here, the 3x cancels. So then you're just left with 5 here. As the 3x multiplies in here, the 3's are going to cancel. The x is still here, so x times 1 is just x. On the bottom, the 3x's will cancel each other out completely, and you're left with x squared minus 25. Once you do this little LCD step, the problem should become way, way, way easier, because you just got rid of that extra little denominator. Question?
Where's this
here, not for the LCD step. You're just multiplying through by that LCD, and then here, then yes, then you simplify it as much as you can. So I like to write the x first, of course, and then we have the factored form on the bottom, and yes, you do have a cancellation of the x plus 5s, and how about a 1 over x minus 5? Good there? So that's the LCD. Step number 1, oh sorry, method number 1 is just separating the numerator and denominator and just sort of simplifying each time. That one probably goes to this right here, practice problem number 2. This is probably when you want to use method number 1. So notice the big bar line. 5x is a pretty easy thing here. That's a simple expression. But on the bottom of this quotient, you have yourself this, whoa, weird stuff. And so at this point then, you want to just simplify, keep on simplifying this until it can't be simplified anymore, and then deal with the 5x. So really we're going to just deal with this whole entire denominator. So 5x on top, I got a 3x minus 4, and we just start dealing with each of these pieces here. So common denominator for this piece, I go with 3, is that right? So this now change this 2, we'll change it to 6 over 3 minus 1 over 3. So notice we're just handling and simplifying. Okay, if that's the case, then that now becomes a 5x over 3x minus 4 over 5/3. Okay, and technically this is a division, right? This is a division between the 4 and the 5/3, so I'm going to change this to multiplication. Again, rewriting it out. It's almost like order of operations. You just kind of keep on simplifying, keep on going. So I'm going to change this into a multiplication problem, which is going to be a 4 over 1 being multiplied by 3 over 5. Uh, 12/5, is that right? So 5x over here, 3x minus 12/5. At that point, let's get a common denominator for the whole entire bottom. 5 is good. So the 3x will change into a 15x over 5. So 15x over 5 minus 12 over 5. Then we get down finally to a 5x, and see now that's going to be a 15x minus 12 divided by 5. So now let's change that to a multiplication problem instead. So this 5x really is going to be a 5x over 1, being now multiplied by a 5 on top and a 15x minus 12. Good there. Give you guys a few seconds to finish it off ahead of me, if you haven't done so already. I gotta do this on the next slide because I'm running out of room here, so let me recopy this problem over to here. So 5x over 1 times 5 over 15x minus 12, and then there if you like, or the factored form if you like. Is that right?